All right, welcome back. Now that our scene is pretty much complete, we're ready to do a final render. So I want to talk a bit about some render settings. Now, before I get into render settings, I want to point out that Arnold has excellent documentation. So if you go to the Arnold menu and go to Help and User Guide, that will open up a new browser, and you can go to Arnold for Maya, expand that, and there's lots of great tutorials and information here to basically answer any question you have about settings in Arnold. Now, I'm not going to go over every single setting. I'm going to kind of glaze over a lot of this stuff, but there's a lot of information here. So you can expand this and go look at something like the rendering, and there's a whole denoising page here. And then if you go up to Arnold render settings, there's some more information here. We can go to the Arnold renderer. So there's just lots of stuff here. There's some tutorials here as well. So don't hesitate to kind of go to that that user guide and look at all the denoising information there if you have a question. There's also, if you go to denoising, in one of these, this talks about the imager denoisers, which we're going to talk about here specifically. And there's also some denoising workflows, so sort of like a questionnaire type thing if your scene is noisy, and how you can fix that. So very good documentation there. Now, in your render settings, we have a few things here, a few different tabs here. Your common tab is going to be pretty much the same no matter what renderer you're using. If we switch this to Maya software, these other tabs change, but your common tab's pretty much going to stay the same. Now, when it comes to denoising your image or getting rid of the graininess or just making it look clear, there's really 4 different things you can do to make that better. And I'm going to skip around a little bit to different sections of our render settings. Now, the first one we've already talked about a little bit in system is your render device. So switching this from CPU to GPU will render your scene a lot faster, but will also result in a lot more graininess and pixelation and noise in your scene. So for a final render, I always recommend doing a CPU render rather than a GPU. To get the similar quality of GPU to CPU, you kind of have to crank up your samples, which I'm going to talk about here in a second, and rely more on denoising, which I'm also going to talk about here in a minute or two. But you're always going to get much better quality with a CPU render. Not only that, but a lot of things just don't work with the GPU render. Some of your nodes don't work with a GPU. Like in my case, my bump node doesn't work. So when I render, my water just is flat. I don't have that bumpiness to it anymore. So, and some of our AOVs will not render either with the GPU, and we'll cover AOVs here in a second as well. So I would recommend just switching this to CPU. That will give you a much more clear and less noisy render all over. The next thing we can do is increase our resolution size. So if we go to the common tab and go all the way down here to our image size and preset, I have mine set to HD 720, which is a good size for sort of like troubleshooting and just doing test renders. But really, for a good high quality render, you want to bring this up to HD 1080. But for now, we're going to leave it at 720 to show you some test renders. And then the other thing that we can do to increase our render quality in the Arnold renderer is to sort of play around with our render samples. And again, there's lots of information in this in the help guide, but we have these samples. And basically a sample is just how many times the renderer is going to look at pixels and sort of make them clearer and clearer and sort of bring them into focus. That's a sort of layman's way to say it, but that's basically what's happening there with our samples. Now you have individual samples for each diffuse, specular, transmission, subsurface scattering, and volume. And then you have camera AAs. Now you can manipulate these individually if you like. If you think that your specularity is very noisy, you can increase the samples of specularity. Now your camera AA is basically going to multiply all of these samples. So basically what these are set at now is a sample of 9. So if we bring this down to 2, right? See, now we have a sample of 4 and bring it down to 1. And we have 1 sample and 0 doesn't really do anything. By default, we're at 3. And for the most part, you can leave it at 3. I'll show you some things we can do to get the graininess out, even if we're at a level 3. But that's one of the ways you're going to increase your quality. So I have some examples here to show you. Now, starting here with this first one, this one is rendered at, again, HD 720. You'll see that it's very grainy. This one is rendered with 1 sample. So this came all the way down to 1, and it rendered very fast. It rendered in just over 1 minute. And then next we have one that rendered around 9 minutes. So 8 minutes and 48 seconds. And this one I had at the default 3 camera AAs. So that rendered a bit longer. And you can see though that it's much less grainy. This one is very pixelated looking, whereas this one is a lot smoother. It still has some graininess to it, but it's not as bad as the other one. And then I bumped it up to 5 samples after that, and we get this result. So I can zoom in a little bit and you can kind of see the difference here. Now this one took about 27 minutes to render. So it does increase your render times quite a bit as you're cranking up that camera AA. But you'll notice that the higher that goes, your quality just gets better and better. Now, I really wouldn't recommend putting this above anything like 6 or 7 because then it's just gonna exponentially increase your render time. Now, one thing you can do if you do want it to go above 6 or 7 is you can come down here to adaptive sampling and enable adaptive sampling, and you can turn this up to something like 10. And what this will do basically is just adapt to different areas that need more samples. So some areas that are really grainy, it will sample them up to 10 times. And some areas that are less grainy, it will sample them up to 3 times. So if you do want to crank this up higher, you can use adaptive sampling. However, I would just recommend at this point to render it at a higher render resolution, which we'll talk about here in a second. The other thing we can look at here is under filter. I think by default this is set to Gaussian. Now Gaussian is great for doing render sequences and animations. We are not doing that. I like using box filter because box just gives you a little bit more of a crisp image when you're rendering. So if you're rendering a still, I would recommend switching this to box. But if you're doing a animation sequence, then you may want to keep this at Gaussian. Now the next thing I want to talk about here is imagers, and specifically denoising imagers. So in your render view here, you have a few different options. You have this little cog here that you can expand out to show this thing. And within here, you have these imagers. Now, there's a lot of cool things in here like lens effects and exposures. But what I want to talk about are the denoisers. So you have 3 options for denoisers here. You have the NVIDIA Optics. This is an AI denoiser. You have the OIDN. This is the Intel AI denoiser. And then you have Noise, which is Arnold's denoiser. This one's a bit more complicated to use. So for simplicity's sake, I'm not really going to talk about this one today. And mainly, I would recommend you use the OIDN because that gives you the best results out of the box. You can add these just by coming up here and clicking to add them, or you can re-add ones you've already created. You'll see that I have a few already created there. And we can enable or disable these here just by clicking on them and enabling or disabling them. Now, to show you some examples of what this looks like when we denoise our images, again, this is at one sample. So this took a little over 1 minute to render. And this is with the OIDN denoiser turned on or enabled. Now you'll see that it does clear things up. It smooths things out a lot, but it also blurs things quite a bit. Next to that, you have the NVIDIA Optics denoiser, which blurs things a lot more. Now, it is possible to get this to look better by sort of altering some of these settings, but out of the box, I feel like the OIDN denoiser works way better anyway. So unless you really know what you're doing and you just have your heart set on using the Optics denoiser, I would use the OIDN, because that's going to give you the best result out of the box. And then we have our 3 samples here that took about 9 minutes to render. And then using the OIDN with that looks way better. So we can compare the OIDN denoiser with 3 samples compared to 1 sample. Looks way better. And then the Optics denoiser, again, it kind of blurs a lot of areas out. I feel like the OIDN denoiser just tends to work a bit better. All right, and then we have 5 samples. So this took about 26, 27 minutes to render. And you'll see that this is getting to be a pretty good quality. We probably don't even need to use a denoiser on this, but if we did, it would just give it a little extra level of polish that you can see there. And then again, the Optics denoiser will blur things a bit more. So just a little comparison there of different results. The last thing I want to talk about here is the AOVs. So let's jump back into our render settings here and look at the AOVs. And now basically what an AOV is a way to break up your render into different layers. So we can separate our shininess or specularity or roughness into one layer. We can separate our volumes into one layer. And this makes it really easy to edit when we get into Photoshop. Now, for this project, the only AOVs I really want to use is the crypto material and the crypto object. Basically what these will do is make a mask for a lot of your objects, and they look like this. So if I come over here to my render and I select this little drop down here, you'll see that I have crypto material, which is going to look like that. And then crypto object, which is going to look like that. And now this is very useful because I can then bring this into Photoshop and I can use this to create masks. And then I can do some really cool things with it in Photoshop to sort of add an extra level of detail to my scene. Now you're going to find those AOVs in this list here. So they're going to be all the way at the bottom. And how you add those to your scene is you just select one. So we have like this crypto asset here, and then I can just click that arrow and that goes in there. And then if I want to take that back out, I can just click that arrow there. So, and then for this next one, I went up in size to HD 1080, only using 3 camera AA samples and the OIDN denoiser. So this one only took about 23 minutes to render, so it took less time than the lower resolution render at 5 samples. And then when I apply the OIDN denoiser to it, I really can't ask for a better result using this resolution. So we can see the difference there in the graininess. So this looks pretty good at this point. I will do another example of a much higher resolution render, in which case it will take much longer to render, but we won't need any denoisers for it, and we'll have just a better result in the end. All right, and now we have what I'm going to call my final render here, which was doubled in size from 1080p. And so I just did HD 1080 here. And then I just clicked maintain with height ratio, and I just changed this to double 1080, which would be 2160. And you'll notice that this is only 2 samples, so this isn't even the default 3 samples, but I turned on adaptive sampling. So that means that it will sample anywhere from 2 to 6 samples, just depending on what it thinks that it needs. I think you'd be fine with just the default 3 samples. And I feel like at this point with this resolution, we're getting into the land of diminishing returns, meaning that it's a bit overkill. We don't, it's not really worth rendering with those highest samples with the resolution that we're getting, because we're getting such high resolution. So we can zoom really closely in here and kind of see the results. So this is very, very high resolution. You can see down here that this took just over 2 hours to render, which, you know, for a single frame at this resolution, I don't think that's such a bad thing. And then I did apply the OIDN denoiser to it. So if we switch to the denoised, you don't really notice a huge difference. You notice a little bit with the rocks. Let me get really close in here so you can kind of see. So there is a bit of the difference with the rocks, so it just kind of smooths some things out. And there's some other areas that it worked really well around. But I did notice also there's some areas that it doesn't really do much. It, you know, like if I zoom in here to the bamboo a little bit, we have some grain in the bamboo. Now, if I switch to the denoise version, it's just kind of a different kind of grain. Or kind of noise. It's still noisy, but it's just a different kind of noise, I would say, which, you know, at the end of the day, when you're this far away, we don't really see it. But basically, I'm going to call this my final render. I did play around with the angle a little bit. I rendered it out at a little bit of a lower angle, and I also, if we look at the camera, I increased my focal length of the camera, so it's more of like an 80 millimeter lens, which basically flattens things out more. It makes it more like an orthographic view, which kind of has the effect of bringing your background closer to you. So I just kind of tweak that, and I think I'm going to call this my final render. So I also have my crypto mats. So I have my crypto material here and my crypto object here, and they have also been denoised. So when you denoise the beauty layer, you denoise the other two as well. And I can just save these from my viewport. So in this situation, I'm just going to save them out as a JPEG. So I'm going to go to my beauty and go to save image, and we are just going to go to the desktop, and I'm just going to save it on the desktop. And I already have some saved here, but I'm just going to, these are kind of lower resolution saves that are at a little bit of a different angle. So I'm just going to rename this to like RGBA high for like high res. And then we can switch to our crypto material, save image as, and for this one, we'll save it as crypto mat, and I'll just put high at the end of that one. And then we have our crypto object, and I'll just do the same, save image. and crypto obj, hi, and save image. So now we have our final renders outputted from Maya. And now I'm going to, in the next lesson or next video, we're going to take them into Photoshop and kind of take a look at all the cool things you can do in Photoshop, all the added detail you can add with different techniques in Photoshop. So I'll see you then.